I'm going to discuss to you how to multiply rational algebraic expressions. Okay, let's have a review first on how to multiply rational algebraic expressions. So say for example, you have your a over b, the first fraction, multiplied to c over d. So a and c are the numerators, b and d are the denominators. So as usual, you just multiply the numerators, a times c, that is ac, b times d, that is bd. And afterwards, you look for their GCF to simplify the final answer. Okay, now let's have examples. Okay, let's have here number 1, 3 over 15 times 5 over 6. Okay? Okay. So, as I've said, just multiply the numerator by the numerator. So, 3 times 5, that is 15. 15 times 6, that is 90. And afterwards, you look for their GCF. 15 to 90, the GCF is 15. So, divide each by 15. So, 15 divided by 15, that is 1. 90 divided by 15, that is 6. Okay, class. This is the usual or the method that you use in elementary. But now, I'm going to discuss to you another method, which is, we're going to use this in order for us to find it easy to find the product. Okay, the simplest product. Okay, so 3 over 15 times 5 over 6. Here we will do cancellation. So to cancel, class, you only cancel numerator by denominator. Okay. Okay, so you have there 3 and 6. 3 and 6. So 3 and 6, you look for their GCF. GCF, of course, 3. So you divide by 3. 3 divided by 3, that is 1. 6 divided by 3, that is 2. And then next, another denominator 15 and the numerator 5. So you look for their GCF, which is 5. So 15 divided by 5, that is 3. 5 divided by 5, that is 1. And afterwards, you multiply the remaining numbers. So that would be 1 times 1, that is 1. 3 times 2, that is 6. Okay, as you observe, class, you come up with the same answer, though different method. But class, we're going to use cancellation method, as I've said, because it is easier for us to find the simplest product. Now, I'm going to give you another example. You have there 5t over 8 multiplied by 4 over 3t squared. Okay. Let's copy. Okay. As I've said, you look for their GCF, numerator by denominator. Okay, let's start with 5t and 3t squared. So, 5 and 3, there is no GCF aside from 1. So, t and t squared, there is GCMF, that is t. So, t divided by t, that is 1. T squared divided by t, that is t. Okay? And then, next is 4 4, and 8. You look for the GCMF or GCF, which is 4. So you have 8 divided by 4, that is 2. 4 divided by 4, that is 1. Multiply. So from your class, you have your 5 and 1. So meaning to say you multiply 5 times 1, that is 5. Times another 1 here, that is still 5. Then here, 2 times t, there is 3. 2 times 3, that is 6. Times t, that is 6t. Okay, that is easy. Okay. Another example. 2x plus 1 over x squared minus 1 times x plus 1 over 2x squared plus x. Okay. Okay, at this juncture, class, as you observe, you have binomials already. So since you have your binomials, so first is you factor each binomial or polynomial. 2x plus 1, that is in the simplest form. Okay, just copy. Two x plus 1 over, okay, for x squared minus 1, this is factorable. Okay, very obvious is difference of two squares. So the factors for that are, so x squared, that is, okay, 2x. So you have your plus, minus. So 1 is square root of 1, or even express that to the exponent of 2, that is 1 squared. So meaning 1 here, another 1. Then multiplied, x plus 1 is also in the simplest form. So just copy. So you have there x plus 1. Okay, 2x squared plus x is still factorable. So you look for the GCMF. The GCMF is x. Okay, so you have there. And then to get the other factor, so again, you divide each term by the GCMF x. So 2x squared divided by x, that is 2x. Then plus, and then second term, x divided by x is 1. Okay, and then now, as you observe, there are common factors. Okay, here, start here. For this, 2x plus 1 and x times the quantity of 2x plus 1, their common factor is the binomial 2x plus 1. So you cancel that out. Cancel that out. Okay? And then, for this, the quantity of x plus 1 multiplied by the quantity of x minus 1 by here, by the numerator, x plus 1. Their common factor is x plus 1. So cancel that out. Okay. So as observed, in the numerator, there is no number, but that means to say, still there is 1. Okay. Why? Okay. Why is it, when you're considering 2x plus 1 class, that means to say, when you divide them, their quotient is 1, meaning there is 1 actually here. Okay? So 1 times 1, that is 1. And then remaining here, then you have there x multiplied by x minus 1. Okay. No need to multiply the denominator. That is the simplest form. Okay, that is the product of 2x plus 1 all over x squared minus 1 multiplied by the fraction x plus 1 all over 2x squared plus x. Okay. Now, let's have Another example. X squared plus 7x plus 10 over x squared minus 4x plus 14 multiplied by x squared minus 6x minus 7 over x squared plus 6x plus 5. Okay. We'll copy in order for you to see the solution. Okay, as you observe, class, you're given here numerator, denominator. They're both trinomial. So, okay, trinomial, so you can use factoring general trinomial technique. But you look also first the GCMF when there is GCMF. So first, x squared plus 7x plus 10. Obviously, there is no GCMF. So proceed to factoring trinomial. So trinomials expected. There are two binomial factors. So start. First term, x squared. So factors x, another x. Next, 10. Your goal is to get 7x. So very clear, class. It's either the 10 is 5, 2. You have also 10, 1. 10 and 1, you add them, that is 11. So you cannot get 7. So perfectly suited here is 5 and 2. So plus 5 plus 2. Okay. Next, denominator. X squared minus 4x plus 14. There is no GCMF. So proceed to factoring trinomial. Okay. First, factor x squared, x. Factor 14 so that this is not positive 14. That is that is not 9 4. That is actually 9. Okay. Okay, this is 9. Okay, so you have here, let's continue. So x, so you look for the factors of 14 that you could get the middle term, negative 9x. So, okay, very obvious, it's negative 7 and negative 2. Okay, next, for the other fraction or rational expression. Okay, x squared minus 6x minus 7. Still, there is no GCMF. So, proceed to factoring general trinomial. So, factor of x squared, x. Factor of negative 7 to get negative 6x is negative 7 and positive 1. And then, denominator, x squared plus 6x plus 5. X squared, factor that, that's 2x. And then 5 to get 6x. So that would be 5 and 1. Okay, now, you look for their the common binomial factors. Okay, start here. This and this. So, their common is x plus 5. Okay, cancel. Here, for this, numerator and denominator. So, common x minus 2. Okay, are there any? Okay, observe. For this numerator and denominator, their common binomial factor is x plus 1. You can also cancel that out as long as numerator by denominator. Okay, cancel. Meaning, remaining is x plus 2 over x minus 2. Okay, now let's have another example. You have x plus 3 over 12 minus 4x times x squared minus 6x plus 9 over x to the power of 4 minus 81. Okay, so for the first rational algebra expression, numerator and denominator are both binomial, while the other, RAE, okay, the numerator, x squared minus 6x plus 9, is a trinomial, while x to the power of 4 minus 81 is a binomial. Okay, so again, you look first for the GCMF. X plus 3, there is no GCMF, so just copy, and that is not also factorable. Okay. However, for denominator 12 minus 4x, as you observe, here the first term starts with x squared. Also for this, x to the power of 4 starts with x. But here, you have negative 4x in second term, and probably the numerical coefficient is negative 4. So class, for this class, in order to get a first term x or positive x, okay, you might be you can get a GCMF which is negative. Okay, so for 12 and negative 4x, so very obvious their GCMF, you can have negative 4. Okay, factor negative 4. Okay, but we're going to, okay, I think I'm going to show this. So 12 minus 4x. So that is, their common is, GCMF is negative 4. 12 divided by negative 4 minus 4x divided by negative 4. So you have negative 4. 12 divided by negative 4 is negative 3. Negative divided negative is positive. 4x divided 4, that is x. Arrange it. So x minus 3. Okay? That's what I mean. Okay, so go back here. Copy. X minus 3. And then you factor x squared minus 6x plus 9. This is factoring general trinomial. So you have two binomial factors. So factor x squared, that is 2x. Then factor positive 9 to get negative 6x. That would be negative 3 and negative 3. And then for x to the power of 4 minus 81, since both of them are perfect squares, meaning to say this is difference of two squares. So you have here, so okay, understand that x to the power of 4 minus 81 expressed first into the power of 2. This would be x squared to the power of 2 or squared minus 81, it's 9 squared. Okay, then you factor. That would be x squared minus plus 9, x squared minus 9. But notice class, this x squared minus 9 still factorable. Difference of two squares. So that would be x squared plus 9. Okay, this is x squared minus 3 squared. You express each term into the power of 2. So simplified, x squared plus 9. Okay, this would be x plus 3 and another x minus 3. Okay, go back here. Continue. That would be x squared plus 9. Another factor, x plus 3. And x minus 3. Okay, next. You cancel their common factors. Say for this numerator and in this numerator 2, denominator, you cancel their common factor, which is x minus 3. X plus 3 rather. And then here for this, negative 4 times negative x minus 3 times the 2x minus 3. So common is x minus 3. So remaining is, here class consider as 1. So 1 times the quantity of x minus 3, that's still x minus 3. Over negative 4 times x squared plus 9 times x minus 3. Okay. Class, no need to multiply the denominator. That's okay. I'll just write this the correct way. X minus 3. You can also erase this. Okay, that's it. That is the product, simplified product of this example. Okay, thank you for watching and hope you subscribe for more videos to come.